So just adding a little layer to what we've been doing. Okay. Once we state, highlight this part, the measurement plus or minus its uncertainty, we are actually saying that the measurement we're reading can actually be above or below the target. Okay? So in general, if you have measurement plus or minus the uncertainty, right? If you have it written like that, forget about this for now. This is going to be very common. I'm going to give you a measurement. You're going to figure out the precision and the uncertainty. Then you're going to come back to the measurement and tack on the uncertainty. And then we're going to state it like this. Oftentimes it stops right here. But it turns out that from this we can get what we call the maximum, or the greatest possible. Guess what we're going to do? We're going to add these two together. That's where the plus comes from. But you can also from this measurement get the minimum, the lowest possible. So you just take the measurement and subtract the uncertainty from it. Okay? So this is finding the uncertainty we know how to do. It's maybe just these two pieces here that that is new to us. Okay? So let's practice that right now. I think I want to add something here. Right away. I'm going to give you one. I'm going to do a small example right here. Example. Let's say a piece measures 45 millimeters, and you see it's plus or minus 0.3 millimeters. You just see that, you're like, oh, that's a measurement with its uncertainty, all right? What would be the max? And what would be the min? What would be the greatest possible measurement? What would be the smallest possible? This would be 45 plus 0.3. That is what? 45.3 millimeters. And the minimum is 45 minus 0.3, minimum minus, right? So hopefully that makes sense. So we take our measurement, we take away the uncertainty, that'd be 44.7 millimeters. This is your example, right? So we're going from our measurement plus uncertainty, and we state the greatest possible measurement from this and the smallest possible. So it could be anywhere in between there. I would have maybe just this even on my study sheet, just this part right here, and just make sure under this number that I gave you here, just write it out like this as well, right underneath, so you know what that is saying. Okay. So here we go. Thermostat in Mr. D's classroom is set to 72 degrees Fahrenheit. State this measurement plus or minus its uncertainty. Okay, so this is what you do. You take precision. Precision is what for this temperature right here? 1 degree, right? 1 degree Fahrenheit. Therefore, my uncertainty is plus or minus half, which is plus or minus 0.5. So let's state it now. Okay, now we have everything we need. 72 degrees Fahrenheit, plus or minus. I'm going to come and find you if I mark your exam and you put down the 1, okay? I know where you live. I'm just kidding, plus or minus 0.5 degrees Fahrenheit, okay? It's the uncertainty that you need to add to your measurement, okay? So what's up with the precision at this point? Nothing. You just needed it to get you to uncertainty, and then we add it on. So this is what I want. This is what the question is asking you to do, right? Take the measurement, figure out the precision, determine the uncertainty, tack it on, you're good. So in this case, this is all it's asking, okay? What if it says State the maximum and minimum temperature in the room. The maximum, guess what? 72 plus 0.5. So that's 72.5 degrees Fahrenheit. Is that better? 72 minus 0.5. So we know it could be anywhere in between, but based on our calculations here, the lowest it could be in this room based on my thermostat showing 72, it could be 71.5, or it could actually be 72.5, right? Anywhere in between, but these are like the limits, so to speak. Okay. Mr. D has plants in the room that need a room temperature of at least 65 degrees. Would it be a good idea to set the thermostat to exactly 65 degrees? Explain using our knowledge of precision and uncertainty. What do we know about 65? Is it possible if I set it to 65 that it goes under 65? Yeah. Not a good idea. Since once the precision and uncertainty has been determined, guys, 65 degrees Fahrenheit is technically plus or minus 0.5 degrees Fahrenheit. That doesn't change. Once you determine what the precision and uncertainty is, it just any temperature I have on my thermostat stays. Oh, sorry, let me bring that up here. Not a good idea, since would indicate, this is like teacher answer, right? You can answer however you want as long as you're making your point comes across. Would indicate that the temperature can fall to 64.5 degrees Fahrenheit, which would probably not kill the plants, but within this context here, we're just saying, hey, 65 is not good because it's going to go under 65, right? Giving that reasoning. So. All right. Where are we at here? I still want a little bit more here. And then you can either go back and do page 15 and 16 or keep going here. Okay. What's the precision of this ruler? Centimeters? What centimeters? These here or these here? These are centimeters, right? Okay. So would it be smart to say 1 centimeter? This precision is not 1 centimeter because there are markings. How many markings are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 gaps. So you have a choice here. Precision could be 1/10 of a centimeter. You can if you want. Or if you divide that, you get 0.1 of a centimeter. That's how you should answer that. Uncertainty would be 0.1 divided by 2, which is plus or minus 0.05 of a centimeter. So that's how you do those. These ones they didn't turn out the way I wanted them. For now, we're just going to ignore this one. But we're going to do this one. What's the precision of this ruler here? If it's fractions, what are we assuming? That this is in inches, right? So you count 1, 2, 3, 4, 5, 6, 7, 8. Guess what? Precision is 1/8 of an inch. Uncertainty is 1/16 of an inch. I'm not going to do the decimal right now because we just did that. What's the precision of this? 1, 2, 3, 4, 5, 6, 7, 8, and another 8, and it does give it away here because you have 16s, right? So I count another 8. Precision is 1/16 of an inch. Uncertainty is 1/32 of an inch. Okay. You can't say I didn't give you enough examples on rulers. Okay. Let's go to, I think I'm going to skip a few here. I will give it a try right here. 20. All right, guys. Same as before, but we're going to state the measurement plus or minus the uncertainty. Do you need me to do one more? Please stop, right? Please stop. But you can't tell me later on. It's like you didn't give us enough examples. Okay, I'll just stop there. I'll come around and help you. The key here is look at the measurement, find the precision, find the uncertainty, then write this thing right here with its uncertainty, right? And then from this answer, you're going to get the max and the min. Just go back to the notes. We just did that. So every thermostat, I want you to kind of look at it and figure out the precision and uncertainty, and then state it like this: measurement plus or minus its uncertainty. Even your phone is happy, right? So I'm just going to leave it up to you for a little bit. I'm going to come around. Make sure you try this. I know it's not always fun to do this unit, but it is doable. Okay, so I'll pause it here and see if we can put it. This is on page 21. If I asked you to measure this using this ruler, you have to measure to the closest marking. So for example, this piece, I know you would guess that it's 16, right? But that's besides the point. This would measure it to 15, okay guys? Because we realized that it's a precision of 5. So in this case, the actual measurement of this piece would be 15 plus or minus whatever the uncertainty is, okay? So try that out.